So today we're going to be taking a look at inverse trig and integration. So this is going to be very similar to what we did yesterday. So remember yesterday we did the arc trigs, the derivative. So like the arc sine of x, we said this was just 1 over the square root of 1 minus x squared. We said the derivative of arc tangent of x, that's a big one, is 1 over 1 plus x squared. And we said we had the derivative of arc secant of x, which was just 1 over x squared of x squared minus 1. So today we're just going backwards. So if we look at the first example right here, we want to take the antiderivative of a squared minus u squared. Now notice this does look like my arc sine, but instead of 1, we're putting an a instead. So let's be careful here. So to this antiderivative, so this is going to give me my my arc sine of x, or in this case, we're going to write it u over a. In the case of our derivative, a is just 1. And then we just don't forget our plus c1 right here. The next one, this looks like my arc tangent because we have 1 over a squared plus u squared. So that kind of looks like my 1 and the x squared. So this is my arc tangent, but we write the answer as 1 over a arc tangent u over a plus C1. Those are terrible looking U's and A's, so let me rewrite those. U and A. There we go. Or U over your A's. All right, moving on. The last one here, there's our arc secant, so this is going to become 1 over A arc secant U over A. And we should put this in absolute values, but again, if you don't, you're going to be fine. Don't worry about it. So a couple things. One, let's take a look here. One, u is always going to be a function of x, where a is going to be a number. It's going to be a constant. And these are actually pretty easy. Oh, look, I said that right down there, where u is a function of x and a is a constant. I should read my own notes sometimes. So let's take a look at an example right here. And this one right here. This looks like my arc sine. So I'm thinking arc sine. My arc sine said it's going to be u over a plus c1. I know it's my arc sine because it matches the same pattern. It's the square root. So my a is going to be the first term. So my a squared is just 1. Because remember, arc sine is 1 over the square root of a squared minus u squared. So my a squared is 1, which gives me a is 1. My u squared is 16x squared. My u then, if I take the derivative, because I need u, is 4x. Now, because this is a actually u substitution, I have to think. This becomes du equals 4 dx, so dx is du over 4. What this is telling us is that we have to divide our answer by 4. So my answer, I'm going to use my rule here, is arc sine of u, which we said is 4x over a, which is 1, plus c1. Now the only thing I need to add is that 1/4, and there's our answer. So you guys try number 2. It's the same exact problem. Don't worry about the 3. The 3 is just a constant. I mean, just leave that alone. So this is my arc sine. So my rule is going to be a arc sine of u over a plus c1. That's what I want to get. So a squared is 1, so a is just going to be 1. My u squared is 4x squared, so my u is just going to be 2x. Now, because I have to do a u substitution, I got to replace my dx, so I got to take the derivative of u2. This becomes just, 2 dx, so we get dx is du over 2. So again, this is telling me to divide by 2 at the end. So my answer is going to be arc sine u, which we said 2x over a, which is 1, plus c1. But I got to bring out this 2 on the bottom, and we also have that 3 as well. We can't forget about that 3. It's a constant, so I got to bring it down as well. And there's our final answer. All right, I'm going to pause the video here, so take a look at number 3 if you want to. We'll come right back and see you in a few minutes.